Dear students, I am Mahesh Javalkar of Maratha Mandal Polytechnic, and today I am posting my fourth DCET video on the subject EMI. Okay, so let's start with the questions. Question number 61: Digital voltmeters convert. Okay, now digital voltmeters will convert what? Analog to digital signal, or digital to analog signal, or current to voltage, or resistance to voltage. It is obviously digital voltmeters will give you a digital output, so it is converting analog to digital signal. So option A is the right answer. So here digital voltmeter converts analog to digital signal. Okay, then we'll go to the next question. Digital voltmeters can be used to measure, okay, voltage only, or voltage, temperature, pressure, etc., voltage and current, voltage and resistance. Okay, basically digital voltmeter is showing you voltage, but it can measure voltage, it can measure temperature, it can measure pressure also, because temperature is an analog signal, then that can be converted into a analog electrical signal, then analog electrical signal can be converted to digital signal, and then you can see it in terms of voltage. Okay, so same even in the case of pressure will be converted to electrical analog signal, then analog signal will be converted to digital signal, and then that digital signal will be shown with in terms of appropriate voltage. Okay, so here option B will be the right one. It is not only voltage, it will show you voltage, temperature, pressure, etc., all these types of parameters. Okay, and then we'll go to the next question. Question number 63: a digital voltmeter reduces parallax error. Okay, obviously because we are not using any needle or pointer over here, the readings is in digital format, and in that case you will get an accurate reading. You don't get any parallax error, you don't get any observational error, so this statement is true. So digital voltmeter reduces parallax error, true statement. Okay, then we'll go to the next question. In a digital voltmeter, a transducer converts. Okay, now whatever parameter you are going to measure, okay, that measured parameter will be in some other energy that can be converted to electrical energy, and once it is converted to electrical energy, then it is shown in a proportional voltage in the digital voltmeter. So here the option C, the input to a proportional voltage. Okay, so in a digital voltmeter, a transducer converts the input to a proportional voltage is the right answer. So answer C is the right answer over here. Okay, then we'll go to the next question. Question number 65: in a digital voltmeter, a signal conditioning circuit is used for what? Okay, so option A is to bring the current to a suitable limit. Option B is to bring the resistance to a suitable limit. Option C is to bring the resistance to a suitable limit. And D is to bring voltage to a suitable limit. So obviously it is to bring the voltage to a suitable limit, because these are conditional circuits like your filters, amplifiers. Okay, so they will see that the appropriate voltage which is coming is to a suitable limit, so that it can be displayed in a proper way and with an accurate value. Okay, so D is to bring the voltage to a suitable limit is the answer over here. Okay, then we'll go to the next question. Question number 66: output in digital form can't be used directly. Okay, this is a false statement, because output of a digital voltmeter can be recorded and can be used for further processing. Okay, so here it is a false statement. So output in digital form can't be used directly is a false statement. Then we'll go to the next question. Question number 67: input range of digital voltmeter dVm is. So there are four options: 1 volt to 1000 volt, 0.1 volt to 10 volt, 0.01 volt to 1 volt, 0.001 volt to 0.1 volt. Okay, now the standard voltage range in a dVm is given between 1 volt to 1000 volts. Okay, it will include automatic range selection and also overload indication. So option A is the right answer over here, 1 volt to 1000 volt. Okay, then we'll go to the next question. Question number 68: What is the effect of IC chips on digital voltmeter? Okay, so options are increase in cost, increase in power, reduction in cost, and increase in size. So out of this, the option C, that is reduction in cost, will be the right answer here, because the cost will come down once your size and power has been reduced to a huge margin. Okay, so here option C will be the right answer, a reduction in cost. Then we'll go to the next question. Question number 69. In electronic voltmeter, the range of input voltages can be extended by using what? Okay, so the options are functional switch, input attenuator, rectifier, or a balanced bridge DC amplifier. The option here is input attenuator. Attenuator is one which can give you selected range, extended range of input voltages. Clear? So input attenuator. Attenuator is a circuit which is made up of a resistance, and it can reduce the highest voltage to a smaller value also. So you can have a range of voltages with the attenuator. So in electronic voltmeter, the range of input voltages can be extended by using input attenuator. So B option will be the right answer here. Then we'll go to the next question, question number 70. Which among the following is not the type of digital voltmeters? Okay, so here options are RAM type or digital voltmeter we are having, integrating type digital voltmeter we are having, potentiometric type digital voltmeter also we are having. None of this. So here, which among the following is not the type of digital voltmeter? So all the above three are digital voltmeters. So answer here should be none of this. D option will be the correct one. Then we'll go to the next question, question number 71. Electrical transducers generate. Okay, the options are biological signals, chemical signals, physical signals, electrical signals. So obviously electrical transducers will convert any non-electrical energy into electrical energy. Okay, so it is electrical signals. So option D will be the right answer here. Then we'll go to question number 72. Electrical signals are easy to amplify. Obviously, electrical signals are easy to amplify, filter, attenuate, anything can be done. So they can go with the signal or conditioning process. So electrical signals are easy to amplify is a true statement. So here the answer will be true. Then we'll go to the next question, question number 73. Electrical transducers are dash. Options are small and non-portable, large and non-portable, small and compact, large and portable. So here the option C is the more advantageous option for electrical transducers, and this is small and compact. So electrical transducers are small and compact is the correct answer here. Okay. Then we'll go to the next question, 74, question number 74. Potentiometer transducers are used for the measurement of pressure, displacement, humidity, or both pressure and displacement. So here pressure and displacement are two mechanical functions which can change the resistance of a potentiometer. Okay, so potentiometer transducers are used for measurement of pressure and also displacement. So here option both A and B, that is the D option, will be the right answer. Then we'll go to the next question. A thermistor is a transducer. Its temperature coefficient is, okay, so its temperature coefficient is obviously negative, because as the temperature increases, okay, the resistance decreases. If the temperature decreases, the resistance increases. So it is going to have a negative temperature coefficient. Okay, so here option A is the right answer. Then we'll go to the next question, question number 76. A strain gauge is an active device and converts mechanical displacement into a change of resistance, or it is a passive device and converts electrical displacement into a change of resistance, or it is a passive device and converts mechanical displacement into a change of resistance. And option D, active device and converts electrical displacement into a change of resistance. So if you read these statements carefully, you can see that option C, it is a passive device. Okay, so it requires external energy to work, so it is a passive device, and it will convert mechanical displacement into change of resistance. So that is the definition of strain gauge. So here option C will be the right answer. Okay, then we'll go to question number 77. The linear variable differential transformer, LVDT transducer, is a, okay, now LVDT, we know that it works on the principle of mutual induction and it is an inductive transducer. So here the option A will be the right answer, inductive transducer. Okay, so LVDT is a inductive transducer. Then we'll go to the next question. Question number 78. If at one end of a two wires made of different materials, okay, two wires made of different materials are joined together, okay, are joined together, then a voltage will get produced between the two wires due to difference of temperature between the two ends. So we can show this something like this. Say this is a junction 1, and if you're taking two dissimilar materials from here, so this is metal 1, okay, metal 1, and this is metal 2, okay, and then you come to here and close the circuit with a reference junction. Okay, so this will be a reference junction. Now here if you connect a voltmeter, okay, voltmeter, then you will get a readings in millivolts, okay, depending on the temperature difference between the junction J1 and J2. So junction J1 will be called as hot junction, and junction J2 will be called as a reference junction or cold junction, whose temperature you know, but you don't know the temperature of junction J1. Okay, so the difference between the temperatures between the two junctions, and depending on the metal 1 and metal 2 composition, we can get a millivolt at the output, a small millivolt at the output, which can be taken as a proportional voltage to the hot junction. Okay, if you know the reference junction or temperature, then how the hot junction is varying, in that way the millivolts will vary. So here the temperature is converted into millivolts. Okay, so this is a concept of thermocouple which works on Seebeck effect. Okay, so here the option A will be the right answer. This is the concept of thermocouple. Then we'll go to the next question, question number 79. With the increase in the intensity of light, the resistance of a photovoltaic cell. Okay, so obviously this relation is an inverse relation. If the light intensity is increasing, the resistance has to decrease. Okay, so a resistance will decrease, okay, if the light intensity is increasing. So it is having an inverse relationship. So here answer B will be the right answer. It decreases. Then we'll go to the next question. Which transducer is known as self-generating transducer? Okay, now self-generating transducer is the name which comes because that transducer is working without any external power. And if the transducer is working without any external power, then it is called as active transducer. If the transducer requires an external power, then it is called as passive transducer. But now in this case, self-generating means a transducer which does not require external power. So that is active transducer. So option A will be the right answer here, active transducer. Okay. Okay, students, this way some another 20 questions which I have taken on a DCET basis of questions on the subject EMI. If you're having any doubts or if you want to give me any feedback, you can leave a comment over here. Okay. Thank you very much.